We're going to look at our second continuous random variable, and this is a z-score. And we're going to spend the rest of our week looking at z-scores and normal distributions. The z-score is a standardized score. What it does is it compares all x values with their means and their standard deviations to see and compare things that have different normal distributions and see which one is better or worse. So what we do is we take our x value, we subtract our mean. Mu is a symbol for mean. X bar is another symbol for mean, but usually what we do is use the Greek letter mu. And then sigma is the symbol for standard deviation. So this is how we find our z-score. Now, a normal distribution curve is going to look something like a bell curve. We have our mean in the middle, and it's separated by standard deviations. Usually there's 3 standard deviations away from the mean, and we'll go more into detail later on in the week. What we're going to do is we're going to standardize the scores, and in this specific example, see who is the best home run hitter in relation to the other players in the league. So we may say Barry Bonds is the best home run hitter because he has 73, but what we're going to do is we're going to compare the home run hitters based on the other individuals in their league and see how much better or worse they are compared to all the other home run hitters. So we're going to start off with Babe Ruth. What I'm going to do is I'm going to find Babe Ruth's z-score, and how I'm going to find that is I'm just going to put a B and an R so I know which one is which. I'm going to take his home runs, which is 60. I'm going to subtract the mean number of home runs by everybody in the league at that time. So in 1927, this was the average home runs that the players hit. And the standard deviation of home runs is 9.7. What I'm going to do is I'm going to take out my calculator. I'm going to subtract 60 from 7.2. I'm going to divide it by 9.7, and I get 5.44. That means that he's 5.44 standard deviations above the mean. So the next one that I'm going to find is Roger Maris. So I'm going to put R and M for Roger Maris. I'm going to find his z-score. I'm going to take the number of home runs that he hit minus the mean number of home runs that everybody hit in 1961. And I'm going to divide it by the standard deviation, which is 13. I'm going to take out my calculator. I'm going to subtract 61 minus 18.8, and I'm going to divide it by 13.4, and I get 3.14. That means that he's 3.14 standard deviations above the mean. So you can see that so far Babe Ruth is far above the mean compared to Roger Maris, even though Roger Maris hit more home runs. So let's look at the z-score of Mark McGwire. So we're going to take his home runs, which is 70. We're going to subtract the mean number of home runs at that year, and then we're going to divide it by the standard deviation of home runs that year. And we're going to take out the calculator, and what we get is 3.88. So that means that he was over 3.88 standard deviations above the mean. So not quite as good as Babe Ruth, but better than Roger Maris in compared with the number of home runs that was hit that year. So the last one that we're going to look at is Barry Bonds. So we're going to take the number of home runs that he hit, 73. We're going to subtract it from the mean number of home runs hit that year and the standard deviation that year. Using our calculator, we get 3.91. So notice that it's better than Mark McGwire and Roger Maris, but not quite as good as Babe Ruth. So Babe Ruth would be the best home run hitter based off of the number of home runs he hit versus the number of home runs that the other players hit in the league. And this is how we find our z-score.